So today we're going to talk about some vocabulary. We're going to be classifying polynomials, and we're going to kind of set up what all the vocabulary that we're going to use in the next few chapters. And so it says we'll be adding and subtracting polynomials tomorrow. In order to do that, first we have to learn about the vocabulary. So what you're going to see here is, and I'm going to highlight a few vocabulary words, is monomial. That's the vocabulary word. These are examples of monomials. It is a variable or a product of variables, meaning it's one item. Nothing is added or subtracted to it. It can still be like a -20 like you have there. It doesn't have to be like a single x. It can have the 4 in front of the x squared, but it is a single quantity or term. Then when you go to two monomials, there's the key, two things are added or subtracted together. We call that a binomial because the word bi means two. Then we have three monomials added together, and that's called a trinomial. And you can see that here, you can count them. That's 1, and that's 2, 3, and so on. 1, 2, 3. Once we get more than bi or tri, we usually just say that there's more than 3, and then we go with the word poly. Poly means many in a prefix, so you can see that it has anything more than 3. So this first one has 1, 2, 3, 4. The next one has 1, 2, 3, 4, 5. It's essentially anything that is more than 3. So mono, 1, bi, 2, tri, 3. So all we're going to do here at the beginning is you're just going to tell me the names of them. So when you look at this first one, I count 1, 2. So when you're going to go ahead and write that down here, we're going to say that this one is a binomial. The next one has obviously 1, 2, 3. So that will make that a trinomial. Clearly this one over here has a lot of them, 1, 2, 3, 4, 5. That makes it a polynomial. If I'm in doubt as to how many we have, a polynomial will always work, unless I'm asking you specifically to name their exact names. But in general, we just call them polynomials, and that includes everything from a monomial all the way up. All right, so you're going to go ahead and finish for me questions. Let's do that in a color so you know you have to do it. You're gonna finish 4, 5, and 6. Now I'm going to talk about a different type of vocabulary. This time we're going to talk about the degree. Degree is essentially talking about the largest exponent. So the degree is the largest exponent in the polynomial. So when I look at this first one, if there are 0 exponents, we call that a constant. So examples of that are like 12. Because remember, anything to the 0 power we know is 1, and then 12 times 1 just equals 12. So we follow the exponent rules that we just finished. Linear, those are the ones that have a slope. They're a straight line. Linear implies that there is exactly one. Linear, notice there's no exponent. It has the imaginary 1 hiding up in here if they don't tell you. Then it continues on up from there. We have 2, if the largest exponent is a 2, we call that a quadratic, and a 3 is called a cubic, 4 is called quartic. The nth term is just that. If it says it's to the 12th degree, then it's the 12th degree, 12th power. So you're not going to name anything probably past 4. There are a few others that actually have names, but we in our class are really going to stop right at, we're going to mostly worry about constants, linear, quadratics. Every once in a while we'll have a cubic, but for the most part we're going to stay with exponents in the 0, 1, 2, and 3 range. So this is what we're going to do. We're going to come down here and we're going to go ahead and name the degree. So again, I'm going to find the one with the largest exponent, which would be here. And for those of us that need the reminder, that's an exponent of an invisible 1. And so because of that, we're going to write down that that is a linear. Okay, so let's look at number 8. This has the highest degree on it. It is a 3, and if you needed the reminder on how to spell it, it's right up here. It's cubic. So I'm going to go right directly below that, and I see I have one to the second power. So you're going to have quadratic. Sometimes it looks like there's only two things, and so it would be really small. But if you notice, that has a fourth power on it. So we're going to call that a quartic. Quartilic. Remember, quartile means 4. So it's a quartic. I would also accept the 4th degree. And then clearly this number 51 over here is a constant. Because there is no variable, or if I needed one, it's actually x to the 0 power, which we know is 1, and 1 times 51 is 1. All right, so that is kind of the notes of the 7.1 lesson. And then what we're going to see here is we're going to now put all of that information into play. So we have just talked about the degree and the name. So the only thing on this page that we haven't really talked about is this leading coefficient, which we have done before. A leading coefficient is the name or the number that is in front of the largest exponents. So most of these, you're going to see that I've already put them in standard form. And what I mean by standard form is when you are writing them, they are supposed to go in order. So if I have something to the 5th degree, something to the 4th degree, something to the 3rd degree, something to the 2nd degree, something with just a plain x, and then a constant of, let's say, 50, they're in order. Now, we won't always have that many things in a row. Sometimes we'll only have a couple of things, or we'll have holes in the middle. But to put them in the proper order, you want to start with the highest exponent and work your way down to no exponent at all. So you end here at the constant. So that's in order. You'll always start with the highest degree, and you work your way down to the constant. Now, that means the leading coefficient has to be on the first term. So when I'm looking at this, let's go ahead and switch to color so I can see it. This is the highest term. The coefficient is there. So I have 3. What was the exponent on it? It was a 2. Anything to the second power is a quadratic. So we're going to go ahead and write that in the box here. So quadratic. Oops, can't spell that today. Quadratic. And then we're going to name it. Clearly, we're going to go back over here and count. There was 1 term, 2 terms, 3 terms. 3 terms was a trinomial. So this one is the number of terms. And again, we use the prefixes, mono, bi, tri, and poly. So when I look at this next one, again, we only have 1 term, but 1 is not going to be one of my answers. The leading coefficient is clearly the 2 out front. And the exponent is clearly up here with a 3. When you have a third power, in case you need to remember, exponents with a 3 are called cubic. So we'll come down here and we'll write cubic. And then there's only 1 term, so this is a monomial. It's a monomial. All right, let's try another one. The highest exponent is the 3. If there is no number out front, remember it is a 1, so my leading coefficient is 1. My exponent is 3. Since I have a 3, it's again a cubic. Those will always match. If this is a 3 and this is a 3, then these will also match. They have to be the same. That's how you identify them. How many terms are there over here? Well, we counted it's 1 term, 2 terms. 2 terms is a binomial. All right, let's look at I'm going to skip a row and come back to, I want to look at number 6. So 6 does not have a leading coefficient. I'm going to say it's NA because there's no variable. Again, there is no variable, so it actually has a degree of 0, because remember, no variable is x to the 0 power. So the exponent is 0. Let's write that so it makes a little bit more sense. So it is just a 0 because this is really x to the 0. Let's put it that way. So it is a constant. There are no variables. It's a constant. There is only one term, so it is a monomial. All right, so my expectation for you is that you're going to go ahead and finish 1, 2, 3, 4, 5, and 6. Now let's talk about what's happening in the bottom section. So the instructions on the bottom section say the order of a polynomial is important. We organize the polynomials in something called standard form, which means we put them in order from descending. So we start at the largest and we work our way down to the smallest. Just what we were talking about before. So if I looked at this example, you can see how it goes: 5, 4, 3, 2, imaginary 1, 0. So that's order. So we're going to rewrite these in exponents from numerical order. So the constant is first, and it cannot be. So remember that minus sign goes with the 2, and the 1 was positive. So when I rewrite it, it looks like that. Notice it says I can circle anything that's already in the correct form. This one is in the correct form. I don't need to do anything to it. So let's go down and look at the one on the bottom row. So clearly we're looking for the one with the highest degree. So I notice that most of them are already in order. It seems to me that these two need to be switched, because 5 is already the highest one, and then 4, and then it should be the 3 one, so the exponent of 3, and then the x to the second power, and then finally the 1. So this would be my answer for this one. And this would be my answer for this one. And so I would like you to go ahead and finish these yellow highlighted ones. So go ahead and finish this assignment, and then you should be able to turn this in on Canvas. And I will show you that real quickly. Let me go back a page. I was on the wrong one. So if you need more information, there's a video link up here. I have completed the 7.1 practice, and you're going to turn it in. And then there is a Math Antics Ed puzzle, simplifying polynomials. And we also, on the quiz day, had a Math Antics video. So this is 2. We had one called What's the Polynomial? And this one is how we're going to be simplifying polynomials when we get to section 7.2. Okay, good luck.